So, I made a video about acceleration, and if you haven't watched it, I recommend you watch it before this video. And so I have 4 graphs here. I have speed and time, speed and distance, time and distance, distance and time. These 2 graphs are going to be a little more boring, but whatever. The point is, my friend, I was telling her about this, and she was like, what about air resistance and terminal velocity? And I was like, oh, I totally wasn't doing that. Right, I said something about that in the first video. But what's more interesting than air resistance, I think, is what happens when it hits the ground. Now, give me a second here. What happens when the ball hits the ground? Let's see, well, this is not too bad. The speed goes down to 0, right? And then at 0, it'll be 0 forever, unless the ball bounces, which I'm assuming it doesn't. How would that look? I'm assuming the ball doesn't bounce, because I didn't think about that for this video yet. So that means the graph looks like this, right? It goes down and then over, and it'll be 0 forever. This graph is interesting, because this is weird, because distance stops. Distance won't increase anymore. But speed still goes down to 0. This graph ends. See, this graph, like, it'll go down to 0, but then it'll still continue on forever because we have time here. This graph just stops because, I don't know, but it's weird. And it's 0. I don't know, but then this graph, wait, which graph? And then this graph is interesting. Well, this graph is actually kind of boring. But you can probably see that time will keep going, but distance will stop increasing because the speed went to 0. And this, you can tell this looks like a ball being dropped and then hitting the ground, except sort of upside down. But then, using this, we can just extrapolate the next one, the last one that I want to show, or we can actually think about it. This graph. Now, distance stops, right? But what happens to time? Time will always keep increasing. So that's weird, because distance stops, distance goes whoopee. There's never going to be any distance. There's nothing over here. X, big X. These numbers don't exist. But time keeps increasing, which means this happens. And I learned about relations and functions in school last year, and I can tell clearly that this is not a function, because this distance value could have any time value. That's just weird. Anyway,